Hello to Darkness344 here, and today I'm going to be doing a very simple tutorial on this bidirectional shift register that works in both Java and Bedrock edition. Also a slight modification, and you can even make it into a barrel shifter over here, which I'll also demonstrate. This shift register is, as I've said, bidirectional, which means you can shift both left and right, basically timesing and dividing by 2 for a binary number. You also have a very good input system, and it's also 2-wide tileable and infinitely tileable, which is quite useful. As you can see, I have repeaters here, and it just still works basically. All you have to do to tile it is add more repeaters for this piston line over here. So first of all, I'm just going to give a quick demonstration of both this shift register and also the barrel shifter. They're basically the same thing, except whenever your number goes off the end, so if I had a 1 here and I shifted it left again, it would normally be deleted on a shift register like this. However, on a barrel shifter, it would go all the way around and back into the least significant bit, or the other way around. It depends which way you have your data. So I'll just be doing a basic demonstration. As you can see, you have this number in, and it's as simple as just clicking a button, you'll shift left. You can just keep doing it multiple times. It's a bit of game lag. And you can do it the other way as well. It is a bit faster than the video is showing. I think my world's just quite laggy. Then also you have a reset over here. And as you can see, you can reset it all to 0. And you can also input data here, like this. There we go. And so just show off the barrel shifter. So let's input some data into one of the ends. Yeah, let's just input this number. As you can see, when we shift it, it goes from that side to this side. And it also shifts the zeros as well, as you can see. And you can of course do it the other way around. So in this tutorial, I'll be basically building just the exact same thing as you see here. For the barrel shifter, I won't show really how to do it. I'll just show how to do it. I won't build it though, because it's very simple. All you have to do is take the output of one end and put it into the input of the other. But I'll basically be doing this tutorial. So first of all, you want to find your area, and we're going to want to build up a bit like this. And we're going to be creating a very, very basic memory cell like this. So with this pattern like this, when you have a repeater and some redstone, whenever I power this dust and unpower it, it stays with a 1, but when I break the dust and place back, it resets to 0. So this is the memory cell, and what we can do is we can use a piston and a block. So if we go up like this, when we have a piston, we can break the cell like that. So if we had a 1 in it, we can set it to 0, just like that. And what we're going to be doing is using this premise to shift. This will just be resetting the cells, and we can use a different mechanism to shift the numbers over. So what we're going to want to do is just build 8 of these, and seeing as it's 2-wide tileable, we only need 1 block in between. So I'm just going to do that real quick. So 1, 2, 3, 4, 5, 6, and 2 more. 7 and 8. So there we go. And then we'll just extend these bits as well, like this. And make sure all these repeaters are on 1 tick, so the register can operate very fast. Then we're just gonna want gaps in the middle, of course. We don't need these blocks, so I'm just destroying them. Then some redstone like this. There we go. Now we're actually gonna be putting the input, so we'll just build using sticky pistons. We're gonna build this bit up like this. And as you can see, we just want the pistons a few blocks above here, as you can see. And then we're just going to repeat this for all of these lines. And then let me just build over like this. So there we go. And you can break the ones in between like this. There we go. And then we're going to have blocks over here, like this. So make sure they're solid blocks, so not like glass or anything. So make sure the block can actually block a redstone signal and can be moved by pistons, of course. Then we'll just have blocks like this. And redstone along here. Now, we're going to be building the input bit. However, this is slightly different on Bedrock to on Java. At the moment, I'm on Bedrock Edition. However, on Java, I'm going to have a in a minute, there'll be a cut and it will show how to do it for Java Edition. So for the Bedrock Edition, we're going to be creating this circuit like this. And as you can see, whenever we have a redstone torch like this, whenever we put an input in, it gives out a 1-tick pulse from that redstone torch, like that. And make sure the repeater's on 2 ticks for that to happen. However, on Java Edition, this does not work, and I'll show you how to fix that in a minute. So on Bedrock Edition, I'm just going to finish these circuits up like this though. And these are our inputs. So over in Java Edition, you do have to make a slight change to the design, but it's a very tiny change. As you can see over here for the input device, we're going to want to, on Bedrock Edition, it's 2 ticks for the repeater, but as you can see, just doesn't work on Java. So you have to turn that to 3 ticks, and it works perfectly fine. As you can see, with on a 3 tick, I think it gives out a 1 or 2 tick pulse. I'm not too sure with Java Redstone, but it still works fine. The pistons do not spit out blocks, and I think I'm in 1.18.2. You can run redstone along pistons now without the redstone breaking. However, if you're in a previous version, you could of course run blocks over like this and run the redstone like that, and it still should work fine. But as you can see, let's just input some data, and we can shift it left and shift it right, and it works just as well as in Bedrock Edition. So just a slight modification on the input and it will work for both editions. So once you finish your inputs, you're just going to want to do a basic test. So of course, Java Edition, you have 1 extra tick on these, but as you can see, as long as all the pistons go down, it is working. And there's a lot of lag, as you can see. But now what we're going to want to do is start the actual memory cells. So it's basically the same for, well, not the memory cells, I mean the actual shifting part of the shift register. It doesn't matter which way you do it, but I'm gonna do shifting this way on this cell. That was kind of hard. Let me draw out now. Shifting this way on this side and shifting the other way on the other side. So what we're going to want to do for that is we're going to block up from here like this, block across like that, and have a repeater on 1 tick and redstone dust. As you can see, we can input into the cell when this piston is down. So if this is down, clearing the cell, we can either input a 0 into the cell, or we could input a 1, and this stops. And as you can see, it's saved whatever we input. And we're going to want this for all of them. Let me just clear this cell. So if we build it over like this, and then we're going to have blocks out like this, and then stone dust behind here like this, and then we're going to break these like this. So now to actually get an input into these things, we're going to want to have a redstone torch. Well, we're going to want to get from this cell to this cell. So what we're going to do, redstone torch over here, block down like this, redstone dust, block up, and another redstone torch. So as you can see, it inverts it again, and goes into this cell. So when this cell is 0, this cell will also be 0, and when this cell is 1, this will also be 1. And then of course, if you set it, this cell will become 1 as well. And we're going to want to copy this circuit for all of them. So I'm just going to put in redstone torches like this, and then we're going to want to put in dust like this in front of the redstone torch, and then block up and redstone torch. There we go. And we don't really need this extra cell on the end unless you want to do a barrel shifter where you'd output that and bring it back into the input over here. Now once we've done this, we're going to want to copy it to the other side, however going the opposite way. So instead of having torches on this side, we're going to have them on the opposite side like this. So once we've put all these torches down, we're just going to want to have the same circuit here. Don't really need this one on the end, but we're going to go across like this. Then of course we need the repeaters on one tick, and redstone dust like that. And then we'll just have the exact same circuit. So we have our redstone torch, go down one, redstone dust, block up one from that, and another redstone torch. So it goes into this cell. And we'll just copy this for each of them. So I'm just going to build across like this, and have our dust in front of these torches, and block across like this. So this design was originally inspired by like a very old Java design. However, I found it didn't work on Bedrock, so I've modified it to work on both versions, as well as include a few more extra parts to it. So this is our basic cell complete. However, we still need an input and an output. As you can see, we can input like that, but that's kind of inconvenient. And we can't really get an output unless we get an output from the same place like that. However, it does work. As we can see, we can shift numbers over if my game doesn't lag as much. There we go. And of course, if you want, you can have buttons for these inputs like that. So now what we want is an actual input system, an output system, and a reset system. So now we're actually just going to want to make our input system. And for that, we're going to input on this side, and we're going to have our output on this side. So what we can do is we're going to need to basically input something to here. And the way we can do this is by having a redstone torch like this, placing a block here, and a redstone torch like this. So if I just reset the cell real quick, actually, will that work? Oh, that'll just shift it. But basically, when I power this, this torch turns off, this torch turns on, and as you can see, the cell gets powered. So we can input along this way. So what we're going to want to do is have this for each of the cells. So let's just go across like this. Place our torches in, of course. And also our blocks over here. And then I'm just going to break these ones in the middle. And now, if we put comparators here, because this will be like a toggleable input, if you don't really care about having this circuit, and you just, whenever you have an input, it will just input into it. You don't need these comparators. You can just have redstone like this. But we'll do it like this because this is quite a good way to do things. Then we have redstone in between, and these are your output over here. So I just put some lamps down to make it a bit fancy, and I'll run some redstone across like this. As you can see, these comparators are on invert, and they also have a redstone dust in between. You can put redstone dust here too, but I don't really like to do that because you don't need it. But now once we've done this, we can place levers like this. And to toggle this input, we're going to go down like this, have a repeater, and block out like this. And then this line can come across over here, and then we're going to do the same thing for each of these cells. So in the middle, we just have a repeater like that. And then of course, this line, you can always add more repeaters like here if you need it. So now that this is done, we can test it out by using a torch like this. Make sure they all turn on, and these all should be locked. So what we're going to want to do is, for now, we're going to have a NOT gate like this. So by default, whenever you try and input something, let's just reset this. It will not be able to input, see? The cell is not changing state even though I'm inputting a 1, and you can click the input button and it will input. So for now, we're just going to have it inverted like that. So now we've added the input, we want to be able to take an output from the cell. And the way we can do this is over here, we actually have this cell has this torch over here going into this block and into this torch over here. But from this block, we can also place a torch on the inside and take an output of the state of this cell from this torch. And of course, we can go down like this and take an output like that. And we're going to need a block here to stop the lines interfering. And this cell is missing something, but you can just build this extra part over here. So I'll just show that. So on this cell where we're missing something, place a torch, go down one, block with redstone on top, and a torch on the inside. And you can go down again and have your output like this. Then we can place redstone lamps or whatever you want. So the way we're going to tile this is just going to have redstone torches on the inside. And of course, if you did your torches if this torch was on the other side, you would need this on the other side over here. Because if this torch was on this side, this torch would also be on this side, and you'd want an output from the cell, and making sure the outputs are in line with the cells, so they're in line with the inputs. So yeah, that's what you do. So I'm just gonna tile this across like this. And then for the end one, just go like that. And of course, we're gonna need blocks on top of these bits to stop the lines interfering. You could alternatively build this one down, but that would just make it a bit bigger. And that's kind of annoying sometimes if space is an issue. But there we go, we now have our output. And we're outputting all ones because we have our input of all ones. Now we have a slight problem, because if, say, I wanted to input the number, well, all zeros, when I input it, it does not work. And that's because this input only inputs ones, it does not input zeros. So the way we're going to fix this is by having a clear function for our cell, for all our cells actually. There's two ways we can do this. The first way is let it all drain out like this, which is as slow as you can see. And the second way we can do that is by, first of all, let me just activate all of this so we can input ones back in again, like this. So as you can see, we have all ones on the output. Don't look at this as the output, as you can see, because it's shifted by one. You want to be looking at this as the output. This is the actual output of the cells. So what we're going to do is over here, where we have the torch going into the next cell, we can block down like this and have a repeater like that. Actually, we could even just do dust like this. And I'm going to go up one, and we're just going to do this for all of them, like this. So we have to do it like this, or this torch will power the line, and we do not want that happening. And this line could be in line with this, but I'm going to just bring it up one because it's easier for the next part. So now we've done this bit, we can toggle all of these off, but then we're also going to need to clear the cells. So what we can do is have a line going into this. So from here, I can just build up like this, and we're just going to go, we'll use, actually we can just build from here, like this. And then this is going to be a bit messy, but it should still work. So there we go. And we want a repeater here, so this line does not make it go down to here. And then when we activate this, as you can see, it clears the cells. So now if you want to input zeros, so say let's input all ones again, like that. So we have an output of all ones. And then say I wanted to input a few zeros as well. Well, if we try and input it, it won't work, as you can see. But what we can do is we can link this reset line up to the input line. So first of all, it resets it like this, and then it inputs it like that. And as you can see, we have what we inputted with the zeros. So all you'd have to do is link this up to this with what you could just use a line of dust or whatever. But yeah, so that's a reset function. And this is quite useful if you just want to reset everything to 0 as well. And yeah, it's just a useful extra thing that some shift registers don't have, especially a bidirectional one. Now for the last part of the video, I'm just going to be going over how to make it a bidirectional one, and I'll just show you how to over here. So the difference on this shift register is the way it shifts is opposite to this one, but it's still the same thing, the same technique. So you, from your last cell, you can have a repeater, and you can go down and have not a repeater, a torch. So from the last cell you take the output, and then all it does is basically comes down like this, goes to another torch, inverts it, goes along all the way under the cells, goes up and goes into this part over here, and the opposite's on this side. So as you can see, from the torch it goes down along here and back up into this cell, and that just works as a shift register basically, or I mean a bidirectional one with a barrel shift register. Yeah, there we go. So yeah, and then last thing to do is just test it out with a lot of piston lag, but as you can see, it works perfectly fine. So yeah, hope you like this video. Please like and subscribe, and I'm out.